about that. And now we're going to go on to Ashan. Ashan?
Thank you. I hope you hear me. Can you hear me?
Yes.
Perfect. I'll share my screen just now. Hopefully you can see that as well. My name is Osian Robert, and I'm a business development manager for Minesto in Wales, believe it or not. So I work in Wales. I'm a Welshman, so I'm a little sad after the rugby result against Scotland last weekend, but we'll leave that there. That's another story. What I want to talk to you about today is the company I work for, which is called Minesto. And the title of this presentation is Opportunities in Low Flow Tidal Stream Energy. And I also did a presentation sort of earlier today, and that was to school children, and I had the same slide, but the title was different. And I wrote Flying Underwater Kites as the title, which is what we do, which is rather exciting. It's a little bit better, more interesting than Opportunities in Low Flow Tidal Stream Energy, and I maybe wish I should have gone for that. So I'll talk to you about what we do, what our history is, what our sort of achievements have been in the UK by using a case study in Wales, and what our potential is to deploy this technology across the world in the future. Now, this slide in itself is absolutely fantastic from our perspective as Minesto, because what it shows, it shows our kite, which is the big yellow thing in the water, sort of being towed to site during commissioning. And the success behind that was our ability to generate power from a low flow tidal stream resource at utility scale at anywhere in the world, for the first time anywhere in the world. And that's really on my doorstep, certainly here in Anglesey, but also, you know, it happening in the UK is a fantastic achievement, and it's something that we are very, very proud of. I've just got a bit of a sticky slide there. Hang on. Okay, so what do we do? I mean, it's a big statement there, an equipment provider of game-changing renewable energy technology. And I do think we are. We're the only tidal stream technology developer currently in the world that's able to harness this low flow tidal energy. Everybody else, you'll see, they go for higher flows. And there's disadvantages to that, and I'm sure there's certain disadvantages to what we do if you compare the two in relative terms. But I feel that what we try and do is, you know, has a great overall advantage to sort of conventional tidal stream technology. We are founded in 2007 as a spin-off from Saab, from the Saab group. And you know what happened there is that there was an inventor in Saab, and he was able to sort of come up with this concept of flying a kite underwater. I'll talk a little bit about how that's done in my next slide. However, that was passed on. There was no real appetite for it at Saab at the time, and it was passed on to Chalmers School of Entrepreneurship, where our founder, a gentleman called Anders Jansson, was able to pick that up as his master's thesis, and prove that was a potentially viable business model. We're funded by two main owners, Midrock New Technology, and that really, in the very far distance away from what we do as Minesto, is funded by a guy called Sheikh Mohammed Al Amoudi, which is from a sort of Saudi Arabian oil money, if you like. But then this person has a great interest in Sweden, where our company is based, and sort of diverted some of his funds to sort of try and tackle this climate emergency we now find ourselves in. Our second owner, which is actually sort of our biggest owner in monetary terms, is BGA Invest, and that stands for Bengt and Gikt Oladson Invest. I think their husband and wife, and they had a business selling beds to IKEA up in Sweden. They sold that, and they decided to invest in something like Minesto, which we're very grateful for, I should say. We're funded through we're funded from the private sector and also the public sector from the European Union. Received considerable funds there, and we're also a publicly listed company on the sort of Nasdaq First North in Stockholm since 2015. The number there is 55 employees in Sweden, UK, and Taiwan. We're closer to sort of 60 plus now, I'd say, and we've seen a total investment of 100 million euros to develop this deep green technology, as we call it. And you can see the iterations there on those pictures at the bottom, where we start with a sort of small kite device being towed by a rowing boat in a lake in Sweden, to some tank testing at sort of tent scale. The first sort of big yellow wing in the middle there, it's our sort of quarter scale device tested in our test center in Northern Ireland. The next picture is the utility scale device that we'll talk mostly about today in Holyhead in North Wales, or Anglesey, North Wales. And the one on the right-hand side, you can see that is our sort of very latest iteration of our deep green turbine. And that's on the quayside in a place called Vestmannarsund in the Faroe Islands. And we're working very hard to deploy our technology there as we speak. There are operations into the night, I think, today. The way the company splits, it's Sweden is where the sort of design takes place. The UK, both testing and quarter scale, and the sort of utility scale testing and operations based. That's where that's located. And we have a guy in Taiwan looking at developing ocean currents, and his name is Dr. Yunglung Chen. Now, I think it's true to say, we're not saying as Minesto, or nor should anyone say that there is a one-stop solution to trying to solve climate change. So, we need this sort of mix, and marine current energy, as we see it, it can contribute significantly to the future energy mix that we need to address the challenges that we see. And you can see Minesto's kite there, or our kite there, and we've got some comparisons to the different kinds of renewable energy technology, and this is where we see ourselves sitting with a significant advantage. We say that the energy produced is predictable with no weather dependency, and and that's certainly true of the tides. They can be predicted to the minute, tens of thousands of years into the future. Ourselves as Minesto, we fly our kites subsea out, and we're below any sort of impact from the weather, because we use deep water with significant expansion potential throughout the globe, which I'll talk about in a second. We don't use we use a minimal amount of land onshore when it comes to substations, but there's really no sort of physical impact at sea in terms of what you can see, visual impact, I should say, because if you look out to sea, our site is completely as you would if there was nothing there. It's under the water, and we believe it can be hugely competitive in the fact that we can bring this levelized cost of energy figure, which is how much it costs to produce the energy, as Javier mentioned earlier, and we can bring that down to 45 euros per megawatt hour by the time we will have 1 gigawatt of capacity installed. When we look to see where we can go in terms of expansion potential throughout the world, you'll see the kind of the darker areas, the reds and the oranges, where people have generally been targeting these are high energy areas, targeting them for conventional tidal technology installations. But we can access the lighter parts, and if you give that a very high level, you know, including the areas where, you know, it might be a little bit too far from land, or the seabed isn't quite right for our installation. You know, there is this huge capacity to produce enough energy to 1.5 times today's nuclear capacity. And why do we need that? I mean, this is an interesting slide. It's actually not my slide, but I took it from a guy in London that worked for a consultancy called Cambridge Econometrics. And really what it's trying to show is that as policy sits today in the UK and heading towards the net zero targets for 2050, should it stay the same as it is today, there'd be no change. There would still be this small gap for energy generation in order for us to meet those climate change targets by 2050. So my point here is that, you know, there is room for this emerging industry that is tidal stream to plug that gap. So our Kite, this is a exciting slide, I think, if you've never seen an underwater kite before, which most people haven't. So it looks like a Spitfire. So you can see, if you imagine holding a stunt kite as a child or as an adult, or if you're a kite surfer, if you hold this, if you stand there and hold the kite in the wind, you can feel the sort of power of that wind just holding the kite in the air. But if you then manipulate that kite and pull it to the left and then pull it to the right, you can make that kite fly this figure of 8 trajectory, which you see on the left-hand side there. And if you've ever flown one of those, you can feel the power that that sort of kite generates by effectively accelerating itself through that sort of wind. And because we do this underwater, we can sort of fly our kite, push that kite with our wing, and use that hydrodynamic lift force from that wing to push the kite through the water, using this and force up to 10 times the amount of water through a turbine that we have attached to the underside of the kite, force up to 10 times the amount of water through that turbine relative to the actual tidal stream speed itself. On the right hand side, you can see sort of in real world video of our quarter scale kites being demonstrated in Strangford Lough in Northern Ireland. You can see as it's sort of moving to the right there now, it's sort of dipping into sort of the depths of that loch, and it'll come up again to the left there and drop again to the left hand side. It doesn't actually come this close to the surface. We've just changed the trajectory, so it's so it's easier to see on a video. We have two product lines. If you'd have talked to us 2-3 years ago, maybe 4 years ago, we've had one sort of utility scale product in design, and that is a sort of a turbine designed to sort of fill the gap in multi-megawatt grid connected tidal farms. You know, up to 3 megawatts in power generation, quite big. Our biggest sort of iteration of the kites with a wingspan of starting at 12 meters, and quite heavy things for us, but in relative terms, quite light when you compare it to conventional tidal technology. Now, the second area where we're looking into is microgrid installations, and that's what we're doing in the sort of Faroe Islands right now. And that's a smaller kite producing a small amount of energy that can be installed for sort of in remote island regions, remote coastal communities, even in sort of luxury tourism areas where in the Caribbean, for example, should there be sufficient flow for hotels to power sustainable hotels or sustainable ports, wherever that application is needed. And if we look at Wales, what I've been doing in Wales, I'll be quite quick on this. If we look at the resource that we can access in Wales, you know, we're up to already looking at sort of trying to, I think exploit is the wrong term, but we'll use it anyway, exploit the sort of resource in the Irish Sea, and that's sort of gigawatts of power that we can potentially access there in the Irish Sea, which brings about sort of untold benefits to the climate emergency that we see in, but also from a socioeconomic perspective, and that social aspect of producing renewable energy, especially in peripheral regions such as Anglesey in North Wales. Our case study in North Wales, we've been around in Wales now, and our office in Holyhead in North Wales is the sort of headquarters of Minesto in the UK. So headquarters of Minesto UK, established in 2015. We have a permitted site there, and the first power plant was successfully demonstrated in 2018, the first picture I showed you. And, you know, of that 100 million total investment into deep green over the last so many years, 51.4 million euros of that has been invested in North Wales and Anglesey in North Wales. And as part of that, you know, the success of Minesto, it's certainly, you know, as technology developers, of course, we want the technology to work, but I would also say that it's absolutely key that we integrate ourselves into the community. And in that respect, we're working with quite a high number, I would say, of local or Welsh supply chain companies, you know, very high standard of engineering from these guys. You know, we need it to be precise, we need it to be of high quality. And these companies, you know, some of them are 2 or 3 people working for these companies as fabricators, as welders, you know, excellent work by them, and absolutely key to the success of our development in Wales. Again, some socioeconomic numbers there, 18 full-time jobs in Wales. 80% of those are what I would say hyperlocal from Anglesey itself. And I'd say out of that 80%, you've probably got 95% of those people speaking Welsh as a first language. Our ambitions in Wales are to sort of phase development, building upon our success so far to get to a 80 megawatt commercial tidal energy array at Holyhead. The first step of which will be a 10 megawatt commercial demonstration array in the next couple of years. This is what we've installed in Wales today. You'll see the kites there on the left-hand side, the tether cable down to what we call the foundation, and essentially the power is transferred down that tether cable along the seabed into what we call a microgrid system buoy, which is a power buoy, which is effectively where we've been offloading the power into. It also acts as a sort of control station, but we can control the kite really from our control station in our office. We sit there by the screen. We have a really high grade data connection that we can relay from where we call Holyhead Mountain from our office to the aerials on this MGS buoy, and control the kite from there. The next step is we will probably move away from this demonstration function or this island function and connect to the grid in the next 18 months or so. And that sort of consenting process is underway right now. Some other nice pictures you see. This is the site. So the top left one is the site. You know, there's a great vista there. It's called South Stack Lighthouse. And you'll see just to the left of that, which is towards Dublin, that's our installation vessel. That's what our little light is. So, and that's what our site, that's where our site is. You know, once we take away the buoy, which you can see on the right-hand side there, it'll just be an onshore connection, and the actual vista will stay the same. So no visual impact. A couple of pictures of the kites being launched, but then another part of the sort of success we've seen in Wales to date is quite new to us. We're quite excited about it, and it is this operations base that we're able to say we now have fully functioning. We have this assembly and maintenance facility. It's effectively a really big shed that we were able to build with Stenaline, and we've leased that, and we are looking to sort of use that to assemble, maintain, and to do any sort of work we need on our kites, and also on the development of our launch and recovery systems and anything else we see fit. And you can see the top right there is the sort of, you'll see the sort of brownfield land there's where the building is right now, and we'll have a constant access to deep water, to a deep water port there, which is excellent. So we will be launching this, opening this virtually in the next few weeks, so keep your eye on that. It's a nice little video, perfect weather. This is how we used to deploy the Kite in the Irish Sea. We've moved away from that now. You know, we can tow the Kite out now and deploy it much quicker, but it's a really interesting video just to show you the sort of size of that utility scale device, and you know, just gives you an idea of some of the challenges. It's not a particularly bad day, you know, it's not a nice day like I mentioned, but it's not a particularly bad day, you know, but there's still all these challenges that we need to contend with when we're launching, you know, something that's hugely novel, hugely innovative in a really emerging industry sector. And I have one more slide after this, but this is a brilliant slide, I think, to just give you another idea of the sort of commercial offer that we have as Minesto. We've talked about Holyhead Deep, what the ambitions are there. Our two other active projects are, the first one is in the Faroe Islands, and we have a collaborative relationship there with a company called SEV or SEV, which is the utility up there in the Faroe Islands. We're installing right now our 100 kilowatt devices, the small microgrid devices I mentioned a couple of slides ago. And the sort of commercial potential there is that we can access towards 70 megawatts of capacity from the tidal resource at the Faroes. And that's really interesting, that project in the Faroes, because the government in the Faroe Islands have given themselves a target of becoming 100% renewable by the year 2030. The third project, our active project, is part of what's called the Interreg Tiger project, where we will be deploying another microgrid system. And it's really exciting for us because, again, we're collaborating there with one of the world's largest utilities, EDF, which are based in France. Taiwan, I talked about the ocean current potential there, and similarly in the United States, we've been working very closely with Florida Atlantic University and a local, they call it a city, little place down there to see how we can contribute to their ambitions of becoming 100% renewable. And of course, ocean currents, we can access those. And the Gulf Stream is really there for the taking if all the variables fall into place at the same time. That is me. This a great picture of Holyhead Deep again, and just to sort of leave you with one thought is that this really could become, I'm speaking from a Welsh perspective, this really could become the sort of new coal industry for Wales, or maybe if we were in Scotland, it could be the new oil industry in Scotland, with the difference being that that resource will last forever. Our resource will last forever. So that's me. Thank you.
Well, that was brilliant. Thank you, Osian. That was really, really interesting. And I think it's interesting having a lot of different perspectives from all three speakers. But it does show how long the process takes from conception to actual commercial use. So